Alright, so let's take a look at enhancing the die class. It seems like we're only doing this thing with rolling of die, but the die class itself is simple enough to give us a good foundation and this idea of creating classes and the objects of them, but also letting us expand the idea rather nicely. So currently, if we look at the die class, what we actually have is the setting of the number of sides to 6. It's hard-coded to 6. Can't change it. This is a 6-sided die. But not all die are just 6 sides. If we think of some examples from the games like Dungeons and Dragons or some more advanced board games, we have die that have different number of sides, from 4, 6, 12, 52. I think there's a 100-sided die out there. We can have die of infinite number of values within a program. These are just random number rolls. We can also have it down to possibly 3 sides or 2 sides. If you think of a coin flip is really just a 2-sided die. So we can control the number of sides. So let's modify our die class here and call it MultiDie. So I'm going to do a save as and create a brand new class called MultiDie. It sounds terrible, like it's dying very many ways, but really this will have multiple faces, more than just the possibility of 6. So 1 and n. So this is user defined, sort of user programmer defined. So another programmer might define it. So now we can make the change here. The number of sides won't be set to 6. So we're going to change this to just be a number of sides. So we should give it some sort of value, but we'll assume that this value is going to come from the user. So we're not going to define it at all. So it's still going to be the maximum face value, but it's not going to be a constant. But now it's a full attribute. It's a proper attribute. So what other stuff do we need to do? Well, the name of the class is going to be called MultiDie. So we're going to call it MultiDie. The constructor is also going to be called MultiDie. So now the question is, what do we want to set the face value to, and what do we want to set the number of sides? So let's assume that 6 is the default number of sides. So we're going to change sides, and we're going to say 6. So unless otherwise specified, this is the default number of sides. So it's going to be 6. Now, set the face value. I'm going to make a modification here. Instead of setting the face value to 1, I'm going to do a roll. I'm just going to do a roll. I've assumed the number of sides is 6, and as soon as the object gets created, we're going to do a random roll. So it's not always going to be 1. We don't know what it's going to be. So as soon as object is created, roll it. So it's right away we got a random value in here. So the roll itself is still going to be the same thing. We're going to be doing it for sides. Same exact idea. But I'm going to tighten up this little piece of code here. So it seems like a lot of work to do, but really what we want to do is set the face value based on this random roll. So why don't we just put the random roll right in there? And you know what? We can. Bam, there we go. So right away, we're just going to go ahead and do that. No temp value used at all. And then we're going to return the face value. So this will set the face value as we do down here. And instead of setting it to max, it will be controlled by sides. Let's see, what else do we have to change? I think that one speaks on its own. We can change this one here to just say die. So it's just the die face itself, or actually let's just call it face. So we're going to just show the face value if you do a toString. I don't think we need to change the equals method, nor do we have to change the copy method. The only reference would be, of course, that this is now a multi-die object, and this is also a multi-die object. No more die objects. We don't want to keep that old class around here. So that should be all good and well. Now, we do have the ability to set the sides, though. So this is now a proper attribute. It's not a constant. It can change its value. So I want to be able to call this in a different way. So let's go to the MultiDie roller, which was just a copy of the previous one. What we're going to do is create two objects. We'll call this one geode A, just because it's multiple faces here, multiple facets, and I'm thinking of a rock, a geode. Let's see, so this will be a new multi-die object. So this will create a new die object, um, and it will be 6 sides, uh, default roll. So by default, we're going to roll it. So I want to create another one here. So we'll call this one multi-die geode B, and it will be a multi-die object, except I'm going to pass into it the number of sides. So I'm going to say this is a 20-sided die. So create a new die object with 20 sides, default roll. So what we have now is another object getting created, but it's going to have a different number of sides. So how do we go ahead and do that? So let me remove all of this code here from the previous one. We're going to write some brand new code. So take a look at this constructor. It's getting passed in an integer. We, we don't have a constructor that matches that. This constructor here matches this constructor here, which is referred to as the default constructor that has no parameters. This, this new one requires some parameters. Again, this is just a method. We have to follow the regular signature rules method. So the method header has to match how we're calling it. So this is actually referred to as the default constructor because it's the name with no parameters. That's what just Java calls it. So what we're going to do is make a copy of this one and call this one the constructor. So this one will have one parameter which is going to be the number of sides. So integer number of sides. So we're going to say that the sides is equal to the number of sides. There we go. So we can actually set it. And the first thing it does, of course, is it does a roll based on the number of sides. So it should be whatever it's getting called to be. So now we have two constructors. We have the default constructor which sets it to 6, and we also have the alternate constructor here which gives us the number of sides. So let's take a look at this class. Let's just compile, make sure our syntax is fine, and it looks like it is. So the multi-die class got compiled as well because we did this compile. Dr. Java is actually very cool for us. So how could we go ahead and do it? So what we want to change is the ability to do the roll. Maybe the roll itself is actually being conducted rather nicely already because it's using the number of sides. Set face value, that one's still being controlled properly with the number of sides. So is get face value and the toString. Everything seems to be working just fine. So I should be able to just display each one of these objects. So for the first one, I'll call it, let's just say A, and this will be the value of geode A, and B, which will be the value of geode B. So keep in mind that when we first created these objects, not only does it set the number of sides, it also does a roll. So we don't even have to roll it. So let's see what values we get coming out of this. So we have for the first one faces 3, for the second one faces 4. Let's try it one more time because we've got that value of 20 sides for the second one. Oh, this is better. Face value of 3, face value of 11. Let's roll again. 2 and 8. Ooh, this is actually getting really, really fancy. We've got a very, very flexible little die here. So we've got two methods that give us this construction. One if it defaults it to 6, and the other one which sets it to whatever is defined as. Now, a couple of quick tricks up here. Remember when we had this as a constant, we had it assigned as a value of 6. This right here acts as part of the construction. So when this object gets created, that attribute sides is initially given a value of 6. If we call it with this constructor, that initial value of 6 will be overridden by this new value. So really, this is not actually very important. We don't actually need to do that. So it's just a side point that if you assign a value up here, it's the very same thing as assigning it down in the constructor. Now, of course, for this one, there is no way to know what the value will be for sides without the object getting created in the first place. So this constructor has to stay the same. But we don't need to define the number of sides inside the constructor if it's a default value. So it's just something interesting. So let's go back and compile. So we've made a change to the code. Everybody's happy. Now, to go back and look at why can't we access face value here directly? So let's take a look, a really brief moment here, just to see what private and public do. So I'm going to show a dot face value, or I'm going to try and do it. So let's see what the value is. So a dot face value. So I'm going to try and access face value. Now for this one, we actually have a real accessor, which is called get face value. So that's the only way we can get the face value back out. But why can't I just access it like this? Well, if I try and compile it, what we should get is an error saying that it can't actually find the symbol. It can't find this thing called, well, I can't find A, so let's recompile that to geode A, and let's do a recompilation. Now we have the arrows expecting. Face value has private access in MultiDie, which means you can't manipulate face value. You can't see it, you can't change it, it's private and it's rather secure. But I could modify this to be public. Now if I compile it, there is no security problem because I can just see the face value. So if I run it, I get the face value of 4, which is what geode is. So this idea of private and public is actually very important. Now that face value is public, nothing stops me from doing something like this. Geode A dot face value is assigned, let's see, negative 5,000. Negative 5,000 is not a valid value. So set face value would not permit this to happen. But there is no security around just changing the value of the primitive. It's public. I can go ahead and change it. So if I compile this guy, I should be able to see that it's now set to a face value of negative 5,000. That's not good. And that's why we want to treat our attributes as private so that we can't do this manipulation. Now, keeping in mind that within the class, within the MultiDie class, as the programmer, I have full control. Security is up to me. But I'm going to make things private or public so that another programmer, which would be somebody writing the main method here, shouldn't be able to change the values in that object without going through the security. Because I don't know who's going to be using my class. Just like the Java programmers, they wrote the string class. That's a very secure class. They didn't know who's going to be using it. Somebody who's just trying to manipulate, somebody who's not very familiar with Java, somebody who's learning it. They wanted to make sure that that object was always going to be secure. So that was actually why they added that method in there. Now, there's also one more question to ask before we finish up with this little example of the multi-die roller. If we go down to the bottom, we see that we've got the equals method and the copy method. The equals method looks and sees if the two multi-die objects are the same. What does that mean to be the same? So if one die equals another one, are we looking at the face value or are we looking at the nature of the die? So if we have a 6-sided die and a 20-sided die, they both show the same face value of 5, but are those die equal to each other? If we're only looking at the face value, yes, they are. But if we're also looking at, are the two die objects the same in terms of the number of sides? No, they're not the same. So that's our question here. What does it mean to be equal to each other? So I'm going to change this and say return true if both objects have the same sides and face value. So I'm going to compare two objects and treat them as equal if they have the same sides and the same value. Or I could treat this equals method and saying only if it's sides. I'm only looking for equality if the nature of the die are the same. Now, this is just an arbitrary decision as a programmer. I've decided to do one or the other. So I might actually end up writing a few equals methods. So I'm going to write one equals method, which is equal full die. So if the full die is the same. So I'm going to do this if everything is the same. So let's write this guy. So if face value of the current object, which would be whichever object is getting called for this method, has the same value as the other face value, and the sides is equal to the other sides. So if these two die not only have the same number of sides, but also if the value is the same, then it's true. Otherwise, it's going to be false. Both of these have to be true for it to be completely true. I'm also going to then write another equals method. Make a copy of this guy. And this would be similar to what we had before. Return true if face values are the same. So in this case, I'm not going to call it the full die equals face value. So in this case, we're now back to just looking at the face value. So I do have two equals methods. This isn't unheard of. With the string class, we have an equals method, and we also have an equals ignore case. So we have a couple of variations there. So I've got two equals methods for this one. Now for my copy method, I don't always want to copy the value. I also want to copy these sides. So I'm just going to do it with the shortcut notation. I'm just going to sides is assigned the value of sides, and face value is assigned the face value. So I'm literally making a clone of that other multi-die object. So how do we go ahead and use these guys? Well, I've got my two die objects here. I'm going to do a quick comparison. So if geode A dot equals full die of geode B, then I'm going to say let's see, die objects are fully the same. There we go. My typing is getting terrible. Now, what if I wanted to do the same thing, but now just look at the value? So in this case, equals face value. So I'm only going to compare the face value. Now I could also do a copy. So in this case, I'm going to say geode B dot copy of geode A. And let's just go ahead and display what the values are. Now to really see that we've made the change for sides, one last thing we'll probably need to do is in the string method here, or the toString method, we're going to show both the sides. So we need to know how many sides there are. And the face value. So we're showing both of them. So we're returning a string that will show us both the sides and the face value. So let's see what happens if we run this guy just as is. Let's see. Oh, I need to fix that comma. So we start off here with our first display. So we see that A has 6 sides and the roll is for 2. For B, it was 20, a 20-sided die, and its roll was 14. We did some if statements. Clearly, none of the equalities were true, but then we made a copy from geode A to geode B that copied both the number of sides and the roll, or the face value from geode A to geode B. So now they're both showing the exact same thing. So clearly, geode B went from being a 20-sided die to being a 6-sided die, and its face value got a copy of that. So our copy method works perfectly fine. But let's see if we can tweak the objects here just a little bit. So what if we assign geode B dot set face value? We're going to set its face value based on geode A. So we're going to have to do a get face value for that one. Now we're going to do it from A to B because B has more sides than A, which means, of course, that if A rolls, it's only going to have a value from 1 to 6, whereas geode B can have a range from 1 to 20. If we did it the other way around, there is a possibility that the value of B would be too big for geode A. So now we'll see if which one of these are true. I don't think this one will be true because this is also comparing the number of sides, whereas the second if statement is only comparing the face value. So what we should see is that the die objects are fully the same. Actually, we should change the wording here. Die objects have the same face. For those of you paying attention, I would be remiss in saying that I made the mistake. So I apologize for that. So let's take a look at it. What we should see is only this statement should actually get displayed because we've made a copy of the face values. And yes, the die objects have the same face value, which is beautiful. So to test this statement here, what we really should do, now we know that they're not the same, let's move it down below. So after we've made a complete copy of geode A to geode B, these should be fully the same. So we should be able to see both of them. And there we go. So we start off with the first one having 6 sides. A roll was at 2. The second one was 20 with a roll of 14. And then the die objects have the same face, which was good after we made that copy. Setting the face value, and then we did a full copy, and at this point the die objects are exactly the same. So let's roll this a few times here. Yeah, so it's rather interesting. Yeah. So this was actually a very good example of adding a second constructor because we want to set up the die object in a little different way because now we have the ability to set the number of sides. So we have a second constructor which gets called with that particular parameter. We also modified the equals method. So now we have 2 equals methods based on the nature of what we're checking. Are we checking everything, both the face value and the number of sides? Or do we only want to look at the face value? And then the copy method makes a copy of all the attribute values from one object into another one. This is a very good example. So we're going to be looking more at classes. We're going to create a more flexible class, but it'll all really be based on exactly what we've been looking at. So if you keep an example of this multi-die roller, we're going to actually be using these same concepts over again. On the next one, we're going to be looking at the puppy class, which is already posted on Moodle, so you can take a look at that one. We'll be talking about that class as an example. All right, see you in the next video.